So today we are discussing optical communication. Okay. So in optical communication, we have to study the optical sources. Optical source part one, that is laser. Okay. So in laser, what we have to study first, understand the introduction of what is laser and the basic concept of the laser. Then after we move forward for the optical emission for the semiconductor things. Then then semiconductor injection laser and some injection laser structure, single frequency injection laser characteristic, injection laser to the fiber coupling, non-semiconductor laser, narrow line width, wavelength tunnelable laser, and mid-infrared and far-infrared laser. And there is some basic problems. We skip that part. Okay. So let me see, is these topic are in our syllabus or not. So single frequency laser mention single frequency laser, so we have to study everything about the laser. Then we move forward for the optical detectors. Okay, so let's see. So first is the introduction of the optical sources. So the optical source is often considered to be a active component in the optical fiber communication system. So optical source is considered this one. So it is a fundamental function is to convert the electrical energy in one form of current into the optical energy in efficient manner, which allow the light output to be efficiently launched or coupled into the optical fiber. Okay, the three main type of optical light source available. So these are wide continuous spectra sources, incandescence lamp, monochromatic incoherent source, that is light emitting diode, and the third one is monochromatic coherent source, that is laser. Okay, let's see once again. So what we explain about the optical sources. So optical source is often considered of the optical fiber communication system. Okay, and it is a basic fundamental functional part that convert the electric energy from in the form of electrical in a form of the optical energy in an efficient manner, which allow that light output be effectively lamp, and second one is light emitting diode, and third is monochromatic coherent source, that is monosingle chromatic coherent source, that is laser. Okay, now to aid the consideration of the source currently in a major uses. So in historical aspect mentioned, in the early stage of the optical communication, the most powerful narrow band coherent source were necessary due to the severe attenuation and dispersion in the fiber. Okay. Therefore, the glass laser, that is helium neon, the glass laser and helium neon are utilized initially. However, the development of the semiconductor injection laser and the LEDs, together with the substantial improvement of the properties of the optical fiber, okay, has give a prominence of these two specific sources. Okay, then we have to see that to a large extent the two source fulfill the major requirement of the so to a large extent two source fulfill the major requirement of the optical fiber emitter, which are outlined below. The first one is a size and the configuration compatible with launching light. So what are the major requirement for the optical fiber emitter? So to large extent the two source fulfill the major requirement of the optical fiber emitter, that is a size and the configuration compatible with the launching the light into the optical fiber. Ideally the ideally the light output Ideally, the light output should be highly diagonal. Okay, so if we configure the size for compatible with the launching the lights in optical fiber, and we also make the light output highly diagonal. Okay, so must accurately track the electrical input signal to minimize the distortion and the noise. Okay, So must actually track the electrical input signal, and to minimize distortion and the noise, ideally the source should be linear. Ideally source should be linear and should emit the light at the wavelength where the fiber has low losses and low dispersion and where the detector are efficient. So we have to make us should in the light should emit a wavelength where the fiber has low losses, low dispersion, where detector are efficient. Okay, these are things preferably capable of simple signal modulation over a wide bandwidth extending from the audio frequency to beyond their gigahertz ranges, and must couple a sufficient optical fiber to overcome and also must couple the sufficient optical power to overcome the attenuation in the fiber pulse, additional connector loss and leave a adequate power to drive the detector. So so these are the major requirement for the optical fiber emitters. Okay, should have a narrow spectral bandwidth in order in order to minimize the dispersion, and must be capable of maintaining the stable optical output which is largely unaffected by the change in the ambient condition. Okay, so it is essential that a source is comparatively cheap and highly reliable in order to compete with the conventional transmission technique. Okay. Okay, so in order to form, so what you have to do. Mm, so in order to form some comparison between these two type of light sources, the historical aspect must be enlarged upon. The first generation optical communication source are designed to operate on this frequency 0 to 9 or 0 to 8 to 09 micrometer. Okay, ideally 0.85 micrometer, because initially the properties of semiconductor material used to lend themselves to the emission at this wavelength. Okay, the first generation, the thing is the first generation communication sources are designed to operate in the range between 0 to actually 0.85 micrometer. But initially the property, because the initially the property of semiconductor material lend themselves to the emission at this wavelength. Also the suggested requirement, 3, this wavelength to avoid the loss incurred in the many fiber near 0.9 micrometer due to the OH ion. These early system utilize the multi-mode. So these early system use multi-mode step index fiber which required a superior performance of semiconductor laser or link for the reasonable bandwidth and distance. Okay thing. And the led being a most being a lower power, actually the led is a lower power source, generally exhibit little spatial or temporal coherence, so was not suitable for the long distance wideband transmission, although it is found used in more of the moderate distance application. So as we know that the LED is not that much of power because it exhibits little spatial or the temporal coherence, and it is suitable only for the it is not suitable for the long distance wideband transmission, although it is found used in the moderate and distance application. Okay. However, the role of LED as a source of optical communication was enhanced following development of the multimode fiber. Okay, and the substantial reduction in the intermodal dispersion provided by these fiber type over the multimode index. So LED emitting in a range of 0.8 to 0.9 wavelength to utilize for the application requiring the wider bandwidth. The position is further development second generation of the fiber operating the length of those second generation fiber operate in the range of 1.6 micrometer. Both material loss and dispersion generally reduced. So the second generation optical fiber uh, operating wavelength is 1.1 to 1.6, and where both material loss and dispersion are greatly reduced. So in this wavelength region, the wideband graded index fiber system utilize the LED sources and may be operated over the long distances, so without the need of any intermediate repeater. Further, LED offer advantage of relatively simpler construction. Okay, LED structure is very simpler as compared to our laser, and the operation with the inheritance effect of these factor on the cost and intended to trouble free life. Okay, in parallel with these later development in multi-mode optical propagation came advance in single mode construction. Okay, so this is so this has a stimulated the development of single mode laser. So these stimulate the development of single mode laser sources which take advances. So the term came. So this stimulated the development of this and mode of laser take advantage extremely low dispersion offered by a single mode fiber. Okay. These systems are ideally suited for the extra wideband and very long haul application and become under sensitive investigation for the long distance telecommunication. On the other hand, light is usually emitted from the LED in many spatial mode and which cannot efficiently focus or couple into the single mode fiber. Okay, so the light usually emitted from the in previously we see that on the other hand the light usually emitted from the LED and in many spatial mode it cannot be efficiently focused or coupled into the single mode fiber. Okay, nevertheless, most recently advancement in LED sources were developed that allow moderate optical power level to launch into the. However, the LED has been utilized primarily as a multi-mode sources. So, however, the today's date the LED usually primarily used for the multi-mode sources, which is acceptable for the coupling efficiency into the multi-mode fiber. And in this capacity, LED remain the major multi-mode sources. Okay. Mm, um, so let's see the basic concept. So in the basic concept, we simply see that the laser and LED both generate light. So lasers simply amplify light using stimulated emission, form in a standing wave inside the cavity, producing high incoherent monochromatic light. And it basically work on the optical oscillator. And in contrast, LED, we studied in previous section, has no gain mechanism or resonator, so it emit incoherent broad spectrum light. That's why lasers are precise and focused, while LED is simpler and more diffuse. So let's see. Let's see. So to gain light generating, so everything okay? Okay. So to gain the understanding of light generating things, to gain understanding of light generating mechanism within the major optical sources use optical fiber communication. So it is necessary to consider both fundamental atomic concept of the device structure. So we have to take up both fundamental concept for the all atomic device structure. In context, the requirement for the laser sources are far more stringent than those of the LED. So the concept of the laser sources are more easier as stringent than the LED. Unlike LED, strictly speaking, the laser is a device which amplify the light. So actually, the laser is a device which amplify the light. Hence, the derivation of the term laser amplifier. The laser stands for the light. Actually, what is? So laser is a device which amplify the light, and in derivation, we term laser as acronym of light amplification by stimulated emission of radiation. Okay, light amplification by stimulated emission of radiation. And laser, however, are seldom used as an amplifier, since these are the practical difficulty in the relation to achieving the high gain while avoiding the oscillation from the of the LED is an optical oscillator. So whenever we have to speak what is LED, so first and LED, laser is a device which amplifies the light, and simply the acronym of the light amplification of stimulated emission of radiation. Okay, and the laser, however, is used as a amplifier, and the practical difficulty in relationship between and the practical difficulty in achieving the high gain while avoiding the oscillator and the energy required required energy feedback. Okay, the practical realization of the laser is practical realization of laser is the optical oscillator. Okay, and the operation of devices may be considered the uh, of the operation of device may described by the formation of electromagnetic standing wave within the cavity. Okay, which provide the output of the monochromatic highly which provide the output monochromatic, okay, highly incoherent radiation. By the contrast, LED provide the optical emission within a inherent gain mechanism. This result is the incoherent light output. In this section, simply elaborate the basic principle which govern the both optical sources. It is clearly, however, that is the operation of the laser must be discussed in some detail in order to provide the appreciation of the way it's function as optical sources. Hence, we can concentrate the first general principle of the laser action. Okay. In this paragraph, we simply understand. Uh, Let me see. Okay, the next part is absorption and emission of the radiation. So absorption and emission of radiation. So simply the interaction of light with the matter take place in a disk. So we simply see. So the interaction of light with matter take place in a discrete packet of energy or the quanta. So it's called photon. So any interaction of light with the matter place in a discrete packet of energy we call quanta and is called photon. Furthermore, the quantum theory and furthermore the quantum theory suggests that atoms exist only the atom that the atom exists only in a certain discrete energy state such that the absorption and emission of light cause them to make transition from one discrete energy state to another discrete energy state. Okay, the frequency of the absorbed emitted radiation F is related to the difference in the energy E between the higher energy state to lower energy state. So what we can say, so difference between energy state is known as this one. Okay, the frequency absorbed by the emitting radiation F is related to the difference between an energy state of the higher to lower. Okay, and here the Planck constant's value is 6.6 into 10 to the power minus 32 joules second. This is Planck constant, and the discrete energy state for the atom may be considered to be corresponded. Okay, so the discrete energy. Okay, and the different state of this one, um and simply So we have take so much time in this section due to error in the due to glitch in the browser. That's why I'm unable to show this. So actually, what is the absorption and the emission? So before reading this section, we simply make a flow chart what actually we have to study. Okay. So in this portion, we simply see the absorption and the emission things. So absorption, absorption and the emission thing, absorption and the emission thing. So what actually we have to do? The light interact with the matter not tick continuously, but in the packet form. So when light interact, okay. So light interact with what? With matter, anything like matter, not in continuous form, okay, not in continuous form. When it interact with the matter, not in the form of packets, okay, packet of energy, that is called photon, okay, that we call photon. And the atom only exists in a fixed, discrete or energy level, not in between. So atom, whenever we say that atom exists, so what we call but it exists in the fixed, discrete or the energy level, okay, energy level, and not in between. When a light interact with this atom, the atomic, so whenever the light interacted with the atoms, okay, interacting with the atom, and the electron inside that atom jump between these energy level. So it jump from the energy level E1 to E2, okay, and the energy difference and the photon energy, okay. Then after we have to study what is energy diff and the photon frequency. So photon frequency. So what you call, if the electron jump from the one level to another level, the energy difference created. So what is the energy difference created? So in case the difference will be E is equal to, energy difference is equal to E is equal to E2, E is equal to E2 minus E1, okay, E1, that we call HF, okay. And here E1 is the higher state, this one is the higher state, mm, this one is the higher state, and E2 is a lower state, and F is a Planck constant. The specific energy always give a specific frequency of the light, and a specific energy is greater than a specific energy difference which give a specific frequency of a light, okay. Okay, so so the three important process, absorption means stimulated absorption when an atom is in the lower state. Whenever the three important process are mm, three mm, three important process are, first one is that uh, first one is absorption. So absorption, okay, first one absorption when an atom in the lower state E1 and the photon with exactly the right energy to hit it, the electron absorb the photon and jump to the higher state, okay. So energy taken from the light goes up and photon disappear, so this is called absorption. So absorption, we simply say that, okay, and the atom in, actually the atom in the lower state, the atom in the lower state, actually it is in the E1, atom in the lower state, that is in E1, when the light strike, when the light and the photon with exactly right energy hit, photon with the exactly right energy hit it, the electron absorb that photon. So electron absorb the photon, okay, and electron absorb the photon and jump in the higher energy state, that is E2, okay. So energy, what is happened? Energy taken from the light. So energy taken from the light, and the light electron goes up, okay, goes up, and after that photon disappear, okay. It is known as absorption. What is spontaneous? So what is spontaneous tenuous emission? Spontaneous emission. So in which we have to, what we have to do? So we simply say that atom eventually want to return to the lower state. Spontaneous, when an atom wants, when an atom wants to return to the lower state. So lower lower states, okay. So lower state. So and the photon is released. In this case, a release of photon happen, okay. Photon happen, okay, but randomly in any direction, the phase and timing, but randomly in the direction, phase. So it is one is randomly. Random in what? For the phase, phase and and timing. So spontaneous emission, in which atom wants to return back to the lower state and releases the photons, and but eventually in any randomly in any direction and any this produce a incoherent light. So after doing this, after doing this, after doing this it after doing this it after doing this, it produce incoherent incoherent light, okay, like LEDs, like LEDs, okay, and normal bulbs, okay. So random, not in phase. So actually it is a random, okay, random, not in phase, not in phase, and not diagonal, okay. Then after, so we studied three type of things. First of all, the first are absorption, then spontaneous emission, whenever atom wants to return to back to its lower state and release the photon, and in randomly in any phase and timing. So it is incoherent light like LEDs and normal bulbs, but random in not in direction. And third one is an stimulated emission, stimulated stimulated emission, okay. So emission in which special, this is a special process. So actually this one is a special process that make laser possible. So especially if an atom is already in excited state. So atom present in already present in excited state. So, okay. When atom is already present in excited state, that is E2, okay. And another photon with the same energy, and another photon, when atom present in another photon with the same energy pass by it, okay, pass by it, it can force the electron to drop to E1. So and it forces the electron to drop to lower state, so E1. So whenever this happen, the electron in it, whenever these things happen, okay, whenever these thing happen, there whenever this thing happen, the the atoms emits, okay, atom emits another photon, okay, photon with same frequency same frequency same direction, same phase, and same polarization, okay. Same frequency, phase same, polarization will be same. So both photon travel together perfectly and make a light coherent, okay, and give a amplification give an amplification, okay. So this is why laser is a, so this is why laser is a, laser is a, laser, what is laser full form? So laser is a full form of light amplification of stimulated of radiation, stimulation stimulate light amplification of stimulated emission of radiation. Okay, light amplification by by stimulated emission of radiation. Okay, so why laser is a unique? Because it is stimulated emission produced and photon, it is identical, same in color, in phase, perfect timing, same direction. Laser is very narrow, same polarization, consistent orientation, so the light enforces itself to amplify a coherent beam. Okay. Mm, as we studied earlier, as we see in absorption, what do we see in absorption? What happened? Low atom in a lower state, photon, actually, in observation what happened when atom in the lower state and a photon with exactly right energy hit the electron, it absorbed the photon and jumped to the higher state. So simply this thing happened, was same when electron in the atom in the lower state, when the energy and the photon with the same energy hit the atom, it get excited and goes to the higher state, that is the final state. In spontaneous emission, atom wants to return to the back load and release the photon energy. So similarly, whenever the atom wants to return to lower state. So in this case, the atoms wants to return to lower state in which a photon is released. Okay, then photon is released the phase randomly in the phase and timing in coherent light like LED and normal bulb. And in spontaneous emission, stimulated emission, when atom present in the excited state. So we simply see that atom present in the excited state. Okay, and another photon of the same energy pass by it. So whenever the photon with the same energy pass by it, it force the electrons to it it force the electron to drop to E1 state, and it emit the energy. Okay, uh, emit the another photon with the same frequency, and also emit the same photon, another same photon with the same frequency, same phase, all the things. Okay. Okay, so till now we have studied this one.